Hmm. Can I go outside and see this, please? Huh? Would I? Yes, you can, ma. The hi, Naisha. Nidhi, what are you doing in school, ma?
We're doing law of sine and cosine and vectors.
But oh my gosh. Okay, but we will finish polar graphs and then go to parametrics, ma. If you want me to, I will go to vectors. But let's see. Nitin, how about you?
Oh, we're about to I think like start a new unit soon, but
What is it on? Is it on parametrics or vectors?
oh no, we have a test on Monday. Yeah, that's what I meant. I don't know what the new unit is. So it's like over do you know like the exact like 3.13, the 3.15?
Hmm. Hmm, hmm, hmm.
Yeah, it's over those.
That's on polar graphing, right? Polar
Y-
graphing, rate of change in polar graphs, right?
Yeah.
Yeah, I get it. After that, don't have.
Um we don't have the calendar for that, but we're gonna start on Tuesday.
Okay. How about you, Vibha?
Auntie, right now we're doing cotangent, secant, all of that, and like converting equations. And yeah.
And then we're also doing trig identities.
Oh yeah.
Oh, triggered, but you're good with trigger identities, Anisha.
Yeah, trig identities is easy.
Okay, let me go over the cart, secant, whatever graph you want, if possible. Meaning, meaning I've collected 2, 3 problems. So let's see whether that is clarifying yours. Otherwise, we will also have. Uh, See, Naisha wanted me to go over one of the topics, so I'll definitely go over. Yashita, you're not studying pre-calc at school, right, ma? Yashita,
Yeah, I'm not.
you're not. Okay. 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 So this is for next year you're learning, right?
Yeah.
Okay, let's see. Okay. Yeah, I see what and all the vertical. Okay, so you want to know about vertical asymptotes. Let's see. Okay. Uh, uh, Nidhi, how about you, ma? Polar graphing you're done now.
Polar graphing is what we're gonna start next week.
Oh, oh, they're just going to vectors and coming to polar graphing, huh?
Yeah.
Then it's still okay for you, right, Nidhi? Meaning whatever we are discussing is still useful, right?
Yeah, it is.
Okay, vectors. Vectors, polar coordinates. They have not even touched on.
We already did vectors. The test is going to be very soon, and right after that, we're doing polar.
Polar, have they covered parametrics? No, not yet. Okay. See, the way the order in which I am going to go is polar graphs. Then I'm going to go to parametric equations. Final one is vectors. Make sense? Okay. 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 Nitin, I just want to know what is your unit, upcoming unit. Okay. I don't see some of them come in. That's fine. I'm going to just move on.
Uh,
Okay.
I don't know my upcoming unit, but it's
No problem, Nitin.
probably 3.16.
There's no 3.16, right? 3.15 closes off, right?
Okay, then I think it's review maybe for AP exam.
Okay. Okay, that's fine. Okay, let's move on. Naisha, shall I go over let's review that. Okay, wait. And guys, I'm trying to get that graphs of cot, secant, cosecant. Let's see. Let's see whether I am successful. Hold on. Mhm. Let's go over doing the graphs of. Okay. Okay, 2 cosecant x. Let's try to plot the graph of 2 cosecant x. Let me share my screen with you guys. Then I will continue the polar graphs that we were doing. Let's see, Naisha, where are we? What are we wanting to understand? 2 cosecant x. Can we plot the graph of this? This we have come across earlier, but just want to go over it for Naisha if that is useful. Otherwise, I'll move on. Okay. How to plot the graph of 2 cosecant x? So the base graph here is 1 by sine x, right? Sine x graph is our base graph. So basically, if it is 2 sine x, right? So what is our midline? What is the amplitude of this graph? Any thoughts? You can just say as well. What
The
is
amplitude is 2, right?
2? Correct, ma. The amplitude is 2. So we'll go ahead with. Let me finish this and then go back to polar graphing. Okay. So the amplitude is 2. This is y equal to 2, y equal to 2, y equal to 0. So basically, sine graph, right? Sine is what I'm going to first plot. Okay. Then only you can plot. The amplitude is 2. So let's say this is pi by 2, pi, then 3 pi by 2, pi, 2 pi. Now, usually the cycle is 2 pi, right? So here, but it is vertical. So 2 is the amplitude, right? So if you substitute, let's say I'm going to draw the sine graph directly. So sine 0 means it's going to be a 0, right? And then what happened? Amplitude is going to be 2. So if I put pi by 2, right? So what pi by 2, I'm going to plot only sine x. I'm not going to bother. I'm going to not bother about the cosecant x at all. So for pi by 2, what is going to happen? It's going to be a 2. Pi, it's going to be a 0 minus 2. Make sense? Okay, but instead, what's going to happen? Here, we are going to plot the graph for cosecant x, right? Meaning 2 cosecant x, okay? But what we write, 1 minute more. What we right now have is only for sine x, right? So first I'm going to plot the vertical asymptote. How are we going to plot the vertical asymptote? See, cosecant x is 1 by sine x. Vertical asymptote is when the denominator is 0. So when will the denominator be 0? See, I have plotted for you 0, pi, 2 pi. All these are vertical asymptotes. Right? Now, you know the vertical asymptote. So how are we going to graph it, right? So here, we are going to go through this, go through. So this is what we are going to go ahead with. This makes sense, right? This makes sense, right? So now vertical asymptotes are, how do you write your vertical asymptotes? Are at points what? I can say n pi. Am I making sense? N pi, n can be from n is equal to 0, 1, 2, goes on. Make sense? This is how you plot the graph for even if it be, see, 2 secant x, the same thing applies. But the problem is you will first plot the graph of cos x. See, here the actual graph of sin x was like this. Okay. So for cosecant x, you'll go ahead and draw from the other end. This is your minimal point, it goes up. Similarly here. So now let's go ahead and try this one. What do I have with me? Yeah, we forgot to plot the range. What is the range of this function? Anybody, what is the range of this function I have plotted? For the cosecant graph, what is the range of this function?
Isn't it all real numbers?
This is not the graph.
Oh, wait, I meant, oh yeah, sorry. Is it,
No.
wait, oh, is it 2,
2, comma infinity on the right side.
yeah,
2
and then
is included.
-3 comma,
-2.
-2?
Here would be minus infinity to
-2.
-2. -2 is included. Make sense? Okay, so that's the range of the graph. Good. Now I would really like you to do, how about this? This is not from your exercise, Naisha, but this is what I have taken. Okay, let's see.
Well, Auntie, I have a question.
Yeah, go ahead.
How do we write the domain for this?
How do we write the
Domain.
domain? Ma, domain is what you tell me.
Since it's just not the vertical asymptotes, do we just say x is not equal to n pi?
Instead of writing the vertical, instead of writing the domain, you just write the vertical asymptotes. They won't usually ask you to write out the domain for these graphs because,
Okay.
see, you will have your exclusions will be a lot more. You see what I mean?
Yeah.
All your vertical asymptotes are exclusions, right? So if you write the vertical asymptotes, it's more than enough. Pi n, I wrote, right?
Okay, yeah. Thanks,
That's
Auntie.
why I wrote, yeah. So now let's go ahead and try secant x minus 1. I just want to review this topic because some of you are not clear. A couple of you at least, for sure. Okay. So secant x minus 1. How to graph this? F of x equal to secant x minus 1. Minus 1 now. Yeah, minus 1. Can we try that, please? I just want to know the range and vertical asymptotes. The intent is for me to find out the range and vertical asymptotes. Are we able to do it? Abhiram, what is the unit that you're covering in school?
We just finished
Mm-hmm.
our
Polar
most recent unit.
Mhm.
Wait, let me check what it was called again.
Sure. No, I just want to know the next. See,
Yeah.
I am ready for parametrics.
It was about complex numbers. So we went over like the theorem for roots of
My
complex
God.
numbers.
Roots of unity they're covering, huh?
Yeah, we already finished that.
That's
We had our
nice.
test on Friday.
Okay. Okay, makes sense. Okay. So what is the next unit? Do you know vectors or parametrics? Hey, go ahead and plot this, guys.
I think it's polar graphs, and
Oh, polar
that-
graphs, you have not done it yet?
we haven't done it in school yet.
Oh, okay. Okay. We'll go there. Okay, we'll go to polar graphing. The last part I have, right? Limicons. We did discuss 3 limicons, but we are not yet that good, I feel. So I'll go back and also cover the rate of change in polar graphs. Those are the
Okay.
last 2 in polar graphing. But I really want to discuss this. Anyway, you're all going to write some exam at the end, right? So this was something Naisha had issues on, and I think Viba's class is also covering it. So I just want to go over this a little bit and then go back. Now go ahead. How about this? Secant graph, what is the parent graph, Manisha?
It's 1 over cos x.
Cos x. So cos x will be my parent function. So when you think about it, it is minus 1 means down 1, right? So cos is usually like this, right? Here is where I have my 2 pi. Because it started 0, the cycle is 2 pi. So here we have pi. Pi by 2, 3 pi by 2. Okay, always this is C, but this is for cos. This is not put down by 1 as well. Okay, so we need to be clear. This is the original cos graph. Now, basically, what do we do? You want to try or you want me to try?
Can we try, Auntie?
Sure. If it comes down, right? First, let me put it down. Because of the minus 1, it has to come down. So just put it down. So let me erase this off. Guys, if you can draw it and show as well, I'm fine. But if you don't want to, you want me to do, let me know as well. You have to clearly let me know what you want. At the end of it, you have to understand that. So if I put it down by 1, it's going to go like this. This is 1, right? So this is going to be 0. This is going to be negative. Again, pi by 2 is going to be, I'm going to bring it down by 1, right? So 2 pi is going to, this is the cos graph. However, what I want is the secant graph. So what do I do? Where are my zeros? How do I detect my zeros? On my, see, this one is y equal to minus 1. This is considered as the 0 line, right? So here what do, it comes down by minus 1. Oh, I'm sorry. So this is minus 1. You go ahead and graph it. I'll graph it too. Y equal to minus 1 should be, this should be half. So this should be minus 1. Oh my gosh. 2, right? Y equal to -1 is only here. Okay, now where are the zeros? These are the zeros. So naturally, wherever is the zero, cos wherever is a zero will become the vertical asymptotes. You want to draw and show? I will do it at the end. Can one or two of you draw and show? So what are the vertical asymptotes? Just tell me what are the vertical asymptotes. One of you can be interactive as well. What are the vertical asymptotes here?
The vertical asymptote is pi over 2 plus n pi.
Yes,
Pi
why?
over 2 plus. So again, this happens up for every, see this distance is pi, right? Pi by 2 plus n pi. Okay, great. Now, how do I graph it? It'll be like this. Oh, here it will be like this. Here it will be like this. Now, what is the range of this function? Vertical asymptotes we did. What is the range of this function?
Is the range of the function negative infinity, comma, -2, and -2 is included, and
Negative infinity to -2.
union 0 included, and
Yep.
yeah.
Any questions on this? Any questions on this?
No.
Okay. Now let's solve one or two complicated functions. Let me try this one. It's a complicated function. How about this? I can give you one or two complicated functions. Let's see. Oh yeah, you can pick it up from here as well. Okay. Let's see. Yeah, let's see. We'll solve one or two complicated functions. I really want to. More, I don't think we solved this in our class. We solved a different set of problems. Today I picked up from somewhere. So let's see. Minus infinity to 0. Okay. Naisha, do you have something that you weren't clear, ma? Or Vibha,
It
you
was
have
it was specifically the question was when there was a phase shift in it, like when
okay.
it was like
Okay.
+1 or +2,
Okay.
I wasn't
Okay.
able
Okay.
to.
Okay. Okay. See this one, right? Okay. Let's try this one. Phase shift minus pi by 2 means what? It is move to the right or left.
Right.
Yeah. We'll see how to graph it. Basically, what is this? What is this? What is this? Right by pi by 2. Then what is this? Half
Horizontal stretch by a
by
factor.
2. Good job. Horizontal stretch by a factor of 2. What is the amplitude, by the way?
The amplitude's 2 because of the horizontal stretch.
Amplitude 2. Amplitude is 2. So let's see. Amplitude is 2 means let's go ahead and draw that. So this 2, this is what function is this? Cosecant. So my base function will be sine. Sin x is my parent function. So it is 0, 2, and we want to go like this. Right? So that's just the base function, sin x function, right? So now I have to go ahead and plot the asymptotes, vertical asymptotes first of all, right? let's try. What are the vertical asymptotes? What are the vertical asymptotes? How to plot it? But there is a horizontal stretch as well, right? In this function. Hold
Yeah.
on. There's a horizontal stretch of 2.
So isn't the period changed to 4 pi?
Yep. Good job. So let me go ahead and graph that. I did not account for that. So let me see. 2 pi. Now, this is 3 pi. This is 4 pi. Now, since there is a horizontal stretch of 2, right? So everything gets multiplied by 2. The period that was 2 pi gets to 4 pi. Whatever your values, right, on the x, meaning whatever you had values, horizontal stretch means the value will get multiplied by 2. The x value would get multiplied by 2. Basically, on a sin x function, 0 was 0, pi by 2 was 1. What did we do? 3 pi, pi by 2 pi, 3 pi by 2, 2 pi. This was for sin x, right? So whatever you had, right? If you multiply, let's see, sin pi by 2 was 0, 1. This one is 0, minus 1 comma 0, right? And then this was a minus 1, this was a 0. So now your x value gets multiplied by 2. So this becomes a pi, this becomes 2 pi, this becomes 3 pi, this becomes 4 pi. See, pi was a 1, 2 pi was a 0, but you have multiplied by 2. So that I need to account for. So basically, pi was a 2, and then 2 pi was a 0. Let me put into marks. 2 pi was a 0, 4 pi is a 0, 3 pi is a minus 2. The problem is everything moves by pi by 2. So what happens? If everything moves by pi by 2, what happens to the int? See, first I plotted here and then that moved here. Now everything moves by this one translated by pi by 2, right? So what happens then? This becomes here. So let me put it in a different color. This moves here, this moves here, this moves here. Am I making sense?
Yeah, auntie.
Naisha, am I making sense?
Yeah.
Okay. So everything moves, right? So let's see. It moves by pi by 2. So 4 pi plus pi by 2, I will try to do 8. Supraj, are you here?
Yeah.
Okay, 8 pi, 9 pi by 2. Okay. So now this one becomes here. So you see my graph, my basic translated or transformed graph, sine graph becomes this. Now where are my vertical asymptotes?
Is it at
Hmm?
pi by 2 plus n 2 pi?
Pi by 2, wait. Pi by 2, there is a vertical asymptote, correct. And then what is this one?
Isn't that 2 pi away?
Is it 2 pi away? Is it 2 pi away? Yes, it is, because this is pi by 2 plus 2 pi. You see, from here to here it was 2 pi, plus 2 pi, right? Yeah, so this one is 2 pi plus pi by 2, right? So this is 2 pi away. Again, from here till here is 2 pi away. So basically pi by 2, sorry, plus 2 pi away for n times, right? So I would say the vertical as Naisha, are you getting Naisha?
Yeah, I think so.
Where are you not getting? You have to let me know.
No, I'm getting when you plot it.
Okay. Okay. Vertical asymptotes are at pi by 2 plus 2 pi n. Okay. Now it's easy to plot the graph. How to plot the graph? This one goes. Oh my gosh. Let me plot the graph in blue. This one goes like this. This one goes like this. Makes sense? This one is here. That's it. We did not plot something else, right? What is that? Range, right? Range is what? From here.
The range is negative infinity, comma 2, which is included. -2, which
Negative infinity to -2 included, and then 2.
and then union 2, yeah.
2 is included, ma. See, for you to plot the vertical asymptote, first go with the sine graph, okay? The basic sine graph. And after that, what do? You have to account for the basic sine graph, but then you have to account for amplitude too. So basic sine graph with an amplitude of 2 I plotted. After that, I saw, oh my God, my x values were multiplied by 2. Sine graph, actual values are in here. This is what I plotted, okay? And after that, I saw there is a horizontal stretch by 2, right? So only my x values were multiplied by 2. That gave sine 2x. So this function became sine 2x. When I multiplied by 2, the x values became pi, 2 pi, 3 pi, 4 pi. The sine 2x graph became this. However, I accounted for this. Basically, this should be 2 minus 2. So I accounted for 2 sine 2x graph. Basically, this is what is 2 sine 2x graph. I did that. And after that, I accounted for the translation. First, I plotted these points. The black points are the 2, 0, minus 2, 0. After I accounted for the amplitude of 2 and the horizontal stretch of 2. Then I got 2 sine 2x, I plotted that. Now the last one should be my translation. So I first plotted my dots. You see here, this. Then finally you can phase shift. You can phase shift that pi by 2. When I phase shifted that pi by 2, every point would move pi by 2 to the right. I moved it. So after moving to the right, those all became the X marks. Okay, this is just the sine graph of what is required. But what you need to do, you need cosecant graph, right? So that you plot it like this, and coming to the vertical asymptote, right? How do you plot the vertical asymptote? Wherever it's crossing the 0 value, wherever your sine value crosses the 0 value, see here, 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 these are the vertical asymptote points. What are those points? What are those points? Pi by 2. So we moved the graph. The movement is not in here, right? So basically plus pi by 2 and then plus pi by 2 plus pi by 2 are your asymptotes. So how do you write that? Pi by 2, this one pi by 2, and then when plus 2 pi, do you see? So plus 2n pi. Any questions? Okay. The last one, I really want you guys to plot and show it to me on the video, guys. And so yeah, I really request you on that. Let us see. How about this? This graph I would really like to see with the asymptotes. How about this? 2 secant 2 theta plus pi by 2. I can literally go over what are the transformation, but I want you to do this. F of x equal to 2 secant 2 theta plus pi by 2. This is a complicated graph naturally. So the base graph is a cos x graph. However, amplitude is 2. See, this one is a horizontal compression by half. This one is left by pi by 2. So what do we do first? I'll wait, guys. If I were you, I would account for 2 cos x. 2 cos x, accounting for it is easy. But draw a table, guys. It won't make you go into a mess at all. I would slowly do one by one. X 0, pi by 2, pi, then 3 pi by 2, 2 pi. Okay, this is what I have. Okay, 2 cos x, let me cos 0 is 1, cos pi by 2 is 1, cos pi by 2 is 0, cos pi is minus 1, and then this one is 0, 2 pi is 0, 2 pi is 1. So now, but the problem is they all get multiplied by 2. See, multiply that by 2. So I will have to account for this. Okay, I only accounted for this. Secant I have not yet accounted for. I have taken as cos. But I did not account for the horizontal compression by half. Horizontal compression by half means what? I'm going to multiply my x values by half. You see? So pi by 4, pi by 2, 3 pi by 4, pi. Oh, wow. Okay. So this one is my, basically I did x by 2. X values I divided by 2. Now I need to account for 2 cos 2 cos x. So that doesn't change at all. That will be the same values. 2, 0 minus 2, 0, 2. So I accounted for the horizontal compression here, and then I accounted for 2 cos graph. Only thing remains is the phase shift. If I want the phase shift of pi by 2, this is pi by 2 plus pi by 2 plus pi by 2. Everywhere you add a pi by 2 on the, I'm sorry, you subtract a pi by 2 on each because you're shifting to the left. We are going to do this, draw the table, plot it, and then do the cosecant secant graph. Can I see your graphs, guys? This one. I'll wait to know what are the vertical asymptotes. But I really want to see. What are the asymptotes? Not a hard one, right? If you're stuck, you're going to let me know. Supraj. Supraj, can you tell me what are the vertical? Yeah, the graph seems okay, but it's a little stretched, I feel. Can you send me the vertical asymptotes?
Okay.
Yeah, that seems fine, but you see, my only problem is I have the feeling it is more, mm, it is horizontally more compressed than what you're showing in the graph. But I may be wrong just by seeing. Can you send me what are the vertical asymptotes?
Yeah, I see.
Oh, wow. Super, good job.
I just
How-
made the graph look more normal, but the values on the number.
I see. That's why. That's what I thought so too. Thank you.
You're welcome.
How are you doing, Superjet school?
I'm doing fine, but like we had the last test we had, like it was so hard. Even some of my smartest friends failed it. My
What,
grade's still not out, but it was like I don't know why she made it that hard.
what was it on?
It was trig solving, except it was 12 really hard questions, and we only had 40 minutes, so the time was a problem. It was like super confusing. I think the average was a 60 or so.
Oh, wow.
Yeah.
Okay, just keep me posted how you do.
Okay.
Ooh, IUB takes it?
Yeah, IUB.
Oh, okay. How are you doing, Abhiram?
Yeah, I'm doing good.
Okay. Graphs, guys. Whoever is not wanting to show, that's fine too. But you have to send it to me in chat. Hey, auntie, I'm not going to show. That's fine. I agree. But then I want to get a message from you. At least one graph I want from you guys. Go one by one. X, then 2 cos x. Then x value you can divide by 2 because here it's a horizontal compression. Then you have to phase shift x values. And then you have to plot the graph between x by 2 plus pi by 2. That's your x value. 2 cos x will be your y value. Going to be small intervals because it's vertically, horizontally compressed. So basically we had, what did we have initially? Pi by 2 pi, 3 pi by 2 and 2 pi, right? Amma, yes, ma. Can you send the vertical asymptotes, Nidhi? So basically, what is this? This is 0 minus pi by 2. So I have to show 1 minus pi by 2 as well. Cos, right? That was 1. That was 2. Oh, wow. Correct, Niti. Pi by 4 is phase shifted to 0 minus pi by 2. Pi by 4 is phase shifted to minus pi by 4, right? So that will be a 0. Now, and then what?
Wait, Auntie, can I show you my graph?
Yeah, please. Vibha, I'm not seeing now. Naisha, you're showing or Vibha is showing?
Oh, nice. Wait, Auntie, can I show you my graph after?
Wait, 1 minute, Naisha. Yes, no. 1 minute, Naisha. Show me, ma, I'm waiting.
Auntie, can I show you? Oh.
Yeah, 1 minute, Naisha. Is that right, Naisha? I am not getting that, Naisha. Cause somewhere we made a mistake, I feel. From your
Ron,
graph. From
Harsha.
your 1 minute, ma. 1 minute, Vibha. Give me 1 minute, okay? Definitely. So now, where am I seeing the flaw? I need to show you where the flaw is, right? Yeah, Naisha, yeah. Naisha, what did you do? Can you show me once more? See, I'm also getting the negative low. Negative low. Where is the 0 point? See, no, Naisha. See, but did you account for the phase shift, Naisha?
Oh no.
Okay,
No, I
let's
didn't.
see. See, that's what we cannot afford to forget. What I would do is, Vibha, you can show me. 2 cos x, we got the amplitudes, ma, but the problem is this horizontal compression and the phase shift. Horizontal compression means x values. See, x value, I'll write it down. 2 pi by 2 pi, 3 pi by 2, 2 pi. That is what you usually need. That seems correct to me, Vibha. That seems correct to me. Can you send the vertical asymptotes?
Yeah.
Now, 2 cos x, right, Naisha, those would become 2 cos x, 2 times, right? Otherwise, it would have been 1, 0 minus 1, 0, 1, right? For me, now it's going to be 2, 0 minus 2, 0, 2, right, Naisha? After this, there is a manipulation on the x. There are two things that we didn't take care. One is the horizontal compression. So multiply every x by half. You see, half x. Then I need to subtract pi by 2 for the phase shift. Both you do. Meaning this value, you're going to half it and minus pi by 2. So this becomes minus pi by 2. This becomes pi by 4 minus pi by 2. Pi by 4 minus pi by 2 means what happens? Pi by 4 minus pi by 2 is what? This becomes 4, this becomes 2, so this becomes minus pi by 4. Do you get it, Manisha? And then again, divide by 2 and then subtract a pi by 2. Divide by 2 and then subtract a pi by 2. So that becomes 0. Now, what happened? 0. No, it can't become 0. Hold on. Minus pi by 2. Minus pi, 0, correct. We are only getting at 0 now only. Okay. See, it becomes so small. Then 3 pi by 2. Again, you divide by 2. If you divide by 2, it becomes 3 pi by 4 minus pi by 2 is 2 pi by 4. So that becomes just a pi by 4. Oh my gosh. Just a pi by 4. And after that, what happens? Divide by 2 and then Divide by 2 becomes pi. Pi minus pi by 2 becomes pi by 2. See? So we are starting at minus pi by 2 going to pi by 2. So that is the only graph we are going to plot. So here, take this. Let me plot the graphs. So these are the two. So here, minus pi by 2 is at a 2. 0 is at a minus pi by 4 is at a 0. See, these are the graphs. And then this one is plotted. Minus 2 is a 0. What is minus 2? I'm sorry, 0 is a minus 2. You see? And then what is this? 0. Pi by 4 is a 0. Let me put it as into marks. And then 2 is a pi by 2. So, make sense? So, this is the graph I get. Am I making sense or not?
Yeah, I just forgot to account for the phase shift.
But you're getting how we are getting it?
Yeah.
It's such a small graph because of the now the actual, this is not the actual graph again. You see, so the actual graph has to be what? So where are our asymptotes? Asymptotes are pi by 4 plus n, pi by 4 plus 1 minute, pi by 4, and then plus n pi by 2. Make sense? Does it make sense for Naisha, Vibha?
Yeah.
Yeah.
Okay. Okay, let's move on. So vertical asymptotes are pi by 4 plus n pi by 2. Peter, mama. Yeah. School Peter. Yeah, go ahead, guys.
I have one question though.
Mm-hmm.
What if your equation asks like instead of plus pi by 2 or like plus pi by 4, what if it's plus 1?
Plus 1, Amma. Here,
Mm-hmm.
it won't be plus 1, right? Because it's
Because the problem that she gave us, it was like plus 1, plus 2 and stuff.
Wait, Nisha, for that, it would have been like horizontally stretched, so it wouldn't be in pi.
I don't know. When we were playing like the game that she gave us, it was like 2 secant 2 and then theta plus 1, and then she asked us to solve for the vertical asymptote.
was it in radians?
Mm-hmm. So I don't know. And she
See,
gave us an answer
okay, I
too,
get
but
it. I get it. See, you can take it as, see, I am taking it as pi by 2 radians. Did you have it as 1 radian?
I don't know. It just said plus 1. That's what.
Ma, why don't you send the question to me, ma?
She hasn't released it yet, but
Yeah,
that was the
whenever
question
she
that we got.
releases it, send the question to me. I'll help you with.
Okay.
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 Okay. Now let's move on. I wanted to go back to polar graphs. Let's go to. Where did we leave the polar graphs? Okay, I don't know. Wait. Have it in there. Polar graphs 3 point. Hold on. 3.14, right? Okay. How about this? I don't know how much of it you remember. Okay, let's see. Don't know this. Okay. Do you remember how to graph this first of all? 3 plus 3 cos theta, or you want me to go over it again? Are you seeing my 3 plus 3 cos theta? Naisha, was it like this, ma? Is this what you're saying? See, Naisha? Is this what you're saying?
No, it was inside the parentheses.
Inside the parentheses, subtracted 1 now.
Mm-hmm.
Ma, then something is wrong. Then the x-axis coordinates.
Yeah, I don't know. I'll ask my
Yeah,
teacher for the
just send it
question.
to me. Send it to me.
Mhm.
We take it as one radian. Okay, let's go ahead. Let's go ahead and see whether we remember these graphs. See, you have to voice out and let me know. Do you remember these graphs? 3 plus 3 cos theta. What type of polar graph would come in? Do you remember? But I need inputs from you guys. 3 plus 3 cos theta, 5 plus 3 cos theta, 1 plus 3 cos theta. Do you remember? This is polar equations, right?
Yeah.
R will be equal to 3 plus 3 cos theta. Do you remember the graphs?
Yeah.
Abhiram, do you remember?
Yeah.
Okay, what type of a graph will come? Let me, you can use calculators, guys. Use calculators. See, what do you get for 3 plus 3 cos theta? Amma, can I go ahead and graph it, or do you want to try graphing it, guys?
Should we graph it on a piece of paper and then show
Yes,
it to
would
you?
be great. Yeah, would be great. But if it's hard, you can let me know as well if you don't remember. I'll go over it. Can I go ahead and plot it, guys? Let me pull up a polar blank graph.
You're on mute.
Sorry, guys. Sorry, guys. So let's go over cos theta graphs first. Cos theta graph, let's say this is 1 cos theta. 1 cos theta means this is 1. this is 1, this is 1, this is 1. It's always right, this is 1. So now cos theta is, it opens right? Cos theta graph is like this, right? How did we do? We plotted tables. We plotted 0, pi by 6, pi by 4, pi by 3, 5 pi by 12. So like this, we had several of these angles, and then the corresponding cos theta we plotted for the R value. This was the R value. This was the theta value. We did try to find these values, and then when we plotted for 1 cos theta, suppose R equal to 1 cos theta, then the graph was like this. Any questions on that? Now, this was just it's a circle graph, right? Now, let's go ahead and try, let's go ahead and review one more. R will be equal to minus 1 cos theta. That time, this opened this side, right? So it was like this. Now, the next one we did was, this was 2 weeks back we did. The next one we did was R will be equal to minus, let's say plus 1 sine theta or plus sine theta. So the graph was like this. Okay. Now the last one was R will be equal to minus 1 sine theta. Any questions on this? Okay. Now if R was minus 6 sine theta. Let me see whether I have so many. No. Okay, let me do minus 4 sine theta. How would the graph be? Anybody?
The diameter of the circle would be 4 and it would open downward.
1 minute. Diameter of the circle, yeah, minus 4 sine theta. So this is 1, 2, 3, 4. So it's going to be like this. Any questions on this? So this all we covered already, right? How did we do this? Meaning just like that, we didn't get a graph. We really plotted the table. This was theta value. This was R value. R was minus 4 sine theta. Theta, you started with all these values, pi by 12, pi by 6, pi by 4, pi by 3, 5 pi by 12. You can put all these values. There was the 1 week that we did this. And then we found out what are the R values. When you plot it, you'll definitely get this. Okay, after all these, we went ahead and plotted rose petals. I don't know whether you remember rose petals. I can review that, but that's going to take a lot of time as well. Let's see. I will review rose petals a little later. Let's go ahead with the limicons now. For the limicon graphs, I came up with this. A plus or minus B cos theta. Let's try that. After this, we had R will be equal to A plus or minus B cos theta. So basically, A and B can be any integer, any values, right? So there were three different categories of graphs. One was A equal to B. Okay. Then you had A greater than B, I think. And then you had A less than B. These were the three categories we discussed. Now, for A, let's say A equal to B. That's what I did now. 5 plus 5. I don't want to take 5. Okay, let's do 2 plus 2 cos theta. Now, if you say R equal to 2 plus 2 cos theta, how are we going to plot it? Basically, when they are equal, right? This is what I showed it in the Desmos calculator. Desmos calculator as well as the GeoGebra are too good with this. I'm going to share it and show you again. Okay. So let's go to a Desmos calculator.
Does it create a cardioid?
Yep, it creates a cardioid. Very nice. Abhiram, it's not yet taught in school, right?
No.
Oh, very nice. Okay. So here this creates a cardioid. Cardioid is a type of limicon, but it is a heart-shaped graph. Okay, it can be this way. Meaning, I'm sorry. Basically, it's a heart. Okay. And then let's do that. Let's do that. Let me do that and show you once more so that you remember. Desmos polar graph demo. Let me share with you. This is what we dealt with last class. Is this what it is? I don't know. 1 second, guys. Chrome. Yeah, I have. Okay, so here is where we did. Remember the sliding. So from here to, okay, I don't want to do this. So first let me do 2 plus 2 sine theta. See here, we start at a 0. Okay, A plus, see, A is equal to 0, and then see how it goes up, 2 plus 2 sine theta. See, when I finish up till 2 pi, I have to, the cycle is till 2 pi, do you see? So when I finish this graph till here, you see, it's a sine theta graph, so positive. Do you see the sine theta wherever it is, it's positive, right? See here. Here it's positive, so it goes up. Whereas if it is a minus, right, what would be the change in the graph? It will be reflected on the x-axis. So the graph would have been like this. Got it? So now let's not go there. Okay, let's first analyze this. So for a cycle of 2 pi, you have a cardioid. Cardioid is where, see, it appears like a heart. And one more, there are a couple of important properties on this graph. When it is a cardioid, right? When you look at this, right? Let's say this is 2, this is 4. Do you see from the pole? Do you see this is 2 plus 2? There is a 4. That's the maximum point to which the graph can stretch. Similarly, at these 2 points, do you see 2 and a 2? 2 on this side, 2 on this side. Symmetrical. Okay, so that's all about this cardioid. Now, suppose if it is, let's say, let's change it and see how it works. As I said, right, let's change it and see. Let's see. I want to change it to a minus. See, did you get it? Now, if it is going to be 2 minus 2 cos theta, how the graph is going to be? You see, it's on the left. If it is 2 plus 2 cos theta, is going to be on the right. Am I making sense? So how do you relate it to the rectangular coordinates? I want you to be able to relate to the rectangular coordinates as well. That's why in the Google Classroom, there is a GeoGebra link that's given. 1 second, guys. I'm going to go to the GeoGebra link. Did I give it to you last class? There was a GeoGebra link which we shared, right? Polar coordinates, polar graphing. Why am I not seeing that in here? 1 second, guys. GeoGebra, polar graphing. See, but I also want you to do with, okay, polar and rectangular. I want to do both. So let's check it. This is good. This is better. Are you able to see the rectangular and polar graphs?
Yeah.
Okay. So basically, I want you to I want to compare both. Okay. So let's see. I want a simple one first. Rose petals we'll do again. The sine, even, sine, odd, cos, even, cos, odd we'll do a little later. See, when I do this, right? See, 2 sine theta graph. It was a simple graph that we already learned. So this distance is 2. Okay, this is up because it's 2 sine theta. But how do you compare both? Turn animation on. Go to the GeoGebra link. I'll share this with you. So when you meddle with this, you will know how it works. You see? So 0 to pi, pi to 2 pi, it completes it. You see? So you need to know this nicely. Okay. See, again, it goes from 1. Okay, now let's see. Let's hold off here. Now, if I ask you, okay, suppose during the period, I am drawing a simple graph, okay, between the period 0 to pi by 2, between the period 0 to pi by 2. So, basically, between the period 0 to the entire graph gets completed in 2 pi. 2 pi is your cycle, right? However, This is pi. When it comes here, it's pi. So 0 to pi by 2 is this part of the graph can be matched up to here. And then this part of the graph, let me put it in a different color, is matched up to here. Now, the next part of the graph, right? This part of the graph, I don't want it in red. This part of the graph is matched up here, right? And the last part of the graph, this one, right, is matched up here. Now, guys, if they ask you, hey, between the region 0 is less than, x is less than or equal to pi by 2, is the graph increasing or decreasing? Is it positive or negative? If you are asked, right, it's often difficult by looking at the polar graph, you cannot say that easily. But when you look at the linear rectangular coordinate graph, it's very easy to tell. See, it is increasing, positive, increasing. Here, positive, decreasing. Here, positive, oh, I'm sorry. Here it's negative, again decreasing. Here it's negative, increasing. Any questions, guys? So when you're asked between, this is a new thing. I did not talk to you about it last week. Between two intervals, if you are asked to tell the nature of the graph, whether it is positive increasing, positive decreasing, negative increasing, it's best to draw its corresponding rectangular graph, quickly look through whether it's positive increasing, positive decreasing, negative decreasing. So if you can understand that, then it's easy, because further when we go ahead, right, they will ask in the polar graph whether it is moving away from the pole or towards the pole. So answering that becomes easy. There is a correlation between, see here it's positive increasing. Here this part of the graph is that, and then this is positive decreasing. This part of the graph is that. So you should be able to relate which part of the rectangular graph corresponds to which part of the polar graph. Now, for now, this is fine. As long as you understand it in rectangular coordinate, it's great. We can correlate that to whether it's moving away from the pole or towards the pole when we get to the rate of change in polar graphs, okay, which I think I'll do it only next week. Okay, but for now, you should be able to relate. Please use the GeoGebra. GeoGebra is very good, okay. See how nicely it relates your rectangular and your polar coordinates. Suppose if it is a cardioid, right, I want to show you that as well. Let's stop this. Let's do 2 plus 2 sine theta. You see, if I turn the animation, I want not from here, guys. Okay, hold on. Theta equal to 0. That's better. See? That's the increasing piece from 0 to pi by 2. And pi by 2 to pi, right? See, it is decreasing positive. Still it's decreasing positive. All are positive values. However, from, see, 3 pi by 2, again it's increasing positive. Am I making sense? The rectangular and the polar graph, you have to be able to connect. You have to draw quickly this graph, and you should be able to say whether during that period is it positive or negative, increasing or decreasing. So that you can state it only from the rectangular graph. Okay, let's go ahead. Now, with this in place, I really want you to be able to let's see. How about this? Okay. 5 plus 3 cos theta. Okay, let's do, so cardioid, you're all very clear. So let's see one more. Oh my gosh. 1 second, guys. Now I'm going to have A is greater than B. That's the next category that we discussed. The last category was A less than B. So let's find out all the three again. Here we did discuss A plus or minus B cos theta or sin theta. Okay. For now, we discussed A equal to B, which formed a cardioid, or cardioid means cardiology, heart. Okay. Now A is greater than B. 5 plus 3 cos theta. Here It's a heart-shaped graph. Here, the second one, let's see, 5 plus 3 cos theta. Stop this one. Hey, Dhyani, are you able to follow?
Yeah, I'm paying attention.
Okay. Now let me turn off the animation. This is going to be greater. 5 plus 3, I don't want sine theta. First, let's do cos theta, please. Okay. How to would I be able to? Okay, let me maybe shorten this 1 plus, let's see, 2 plus cos theta. That's fine. 2 plus 1 cos theta, right? So that's better. It's a small graph. So let me change my values. Only thing is A should be greater than B. 2 plus 1 cos theta. Now, do you see there's a big difference? Here, it's called a dimpled limicon. All these are limicons, okay? We are only discussing limicons again today, okay? So here, this is a dimple limicon. Why the dimple limicon? This one, right, it doesn't get the shape of a heart, but it has a dimple to it. Limicon or limicon, okay? So this is a dimple limicon. However, there are some properties that you need to see. There is a 2 plus 1 cos theta. Because of the plus, it opens on the right, okay? Dimple is on the left. However, do you see this one? See, this short distance is 1. The short distance is 1. The subtracted value of these two. But then, how about this? This one, right? This is 2 plus 1. A plus B. This is A minus B. Any questions? This is A, this is B. So for the dimple limicon, it is always the dimple happens at A minus B on the other side of the bulb. Whereas this side, it's A plus B. Suppose if the same graph becomes 2 minus 1 cos theta, what happens? What happens, you think? 2 minus 1 cos theta?
It'll open up on the left,
Yep.
and like the dimple will be on the right.
Yeah, let me go ahead and do that. 2 minus 1 cos theta. Yeah, everything will be the same, but did you see it will open up on the left, but the properties all remain the same. Since it's a dimple limicon, this side is 1, A minus B, and this side will be A plus B. So now, if I change the values, right? Let me change the values and show you. So here, let's not take 2 and 1, okay? That seems easy to me. Now, 3 and 2. If I have this, you see, again, the properties remain the same. 3 minus 2, this is 1, this is 5. Am I making sense? Am I making sense? Nidhi, are you following my?
Yeah, I am.
Okay. So, how about this? 3 minus 2 sine theta. How the graph is going to be? Let's erase all of this. So 3 minus 2 sine theta. First of all, sine theta should be up. But then there is a minus 2 sine theta. So basically, this side is going to have here. Okay, but the dimple is going to appear here. Right? And then, so the dimple is going to appear here. It's going to be a dimple. It's not going to be a heart, right? So it's going to be something like this. Am I making sense? Minus 2, yeah. So let's try that out. 3 minus 2 sine theta. I don't want me to do 3. 3 minus 2, I said sine theta, right? Play with it and see when you have time. Does that make sense? Does it make sense? Or do you need...
Yeah, it makes sense.
Okay. So we have discussed only A equal to B, A greater than B. But I really want to discuss A less than B as well. But before I discuss, let's see. Inner loop, okay. Here when A greater than B, one thing you need to understand is A by B value. This one I forgot to tell you about. In this case, A by B value is between 1 and 2. A by B values between A by B values between 1 and 2. That's the restriction that you should remember. Okay. The last one is A less than B. That's the last type of limicon. This is a inner loop limicon. Inner loop limicon. Okay. So this one, let's see how the graph is going to be. Let's say A is less than B, right? So I should shift this 2 minus 3. I want to put cos theta first. Do you see? So here it's a very different one. Inner loop limicon, there is an inner loop out of the outer limicon. Apart from the outer limicon, you also have an inner limicon. Here, when A is less than B, right? So we did 2 minus 3 cos theta. So for this one, what happened? Do you see 2 minus 3 cos theta? See, because of the minus, it appeared on the left. It is a cos theta graph, so it has to be symmetric about the x-axis, okay? And sine means about the y-axis. But see the A and B values. See what is going on. Here, 3 plus 2. This one is 3 plus 2. The maximum diameter, maximum width across the graph is 5. That is 3 plus 2. Whereas, do you see the inner limicon? So when I am giving you the graph, you should be able to write the equation. That's what I'm coming to. So the inner loop limicon will be this value minus this value, 3 minus 2. You see? So that will be the inner loop. If it was 2 minus 3, it won't be a inner, if it was 3 minus 2, it won't be a one inner loop limicon, but it will be more of a dimple limicon. Now I have A, this is A less than B. So in this case, it will be a inner loop limicon. Inner loop will be 1. So the maximum width of the graph would be the added value of these two. Any questions? Suppose let's say I want to change the graph to 2 plus 3 sine theta. How is it going to be? What type of graph is that? 2 plus 3 sine theta. 2 plus 3 sine theta. Any thoughts? At least one or two of you would have understood. 2 plus 3 sine theta. What happens to that? How would the graph
That'll
be?
be an inner circle.
It would
There will be an inner circle, up or down?
up.
Up.
Up. So it would be 5. It will be somewhat here. That will be the maximum point. But what happens? 2 plus 3 means up, okay. And then
Wouldn't it be 2 minus 3 is the inner limicon?
inner circle. So that would be 1, right? Right? It'll be like this, right? Let's see. Let's draw it and see. Let me erase mine though, because it's confusing. See, make sense? Let me erase mine, please. Let's discuss the widths though. Here, as we said, right, we are good, meaning the farthest point is 5. This inner loop is 1. That we understood. 3 plus 2, 3 minus 2. And here you see it's 2, 2. This one. Make sense?
Yeah.
So those 3 types of limicon is enough for today. For next week we'll revise rose petals. Try to plot Archimedes spiral. Okay, and then I'll go into rate of change of polar graphs. Rate of change in polar graphs. Okay, but I really want you to be aware of limicons of the format A plus B cos A plus or minus B cos theta sin theta. So the 3 categories are 1 A equal to B, A is less than B, A greater than B, and A less than B. So A equal to means it's a cardioid hard graph. A greater than B is going to be a dimple limicon. A less than B is going to be a one loop limicon. Okay, with that we'll conclude, and based on cos or minus cos or sine or minus sine, you will find out the where the bulb comes up, so that you decide based on that. Okay, and then the cycle is pretty easy as we move up. I'll concentrate on cycle. To cycle, I did not worry about it much. Some have pi, some have 2 pi. You should know it, but we will do. One another thing is you should be able to correlate a rectangular graph with the polar graph. That is so important when we go to rate of change in polar graphs. Shall I stop here? Okay. I'll stop here. We'll come back to this next week. And Naisha, let me know, Naisha. Tomorrow, bring that
Yeah,
or
of
whatever.
course.
We'll coordinate, ma. Yeah, guys. Have a nice week ahead. If you have questions, stay, guys.
Thank you
Right,
so
thank
much,
you.
Auntie.
Bye,
Bye.
Auntie.
Bye.
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 Thank you.
Bye. Guys. Okay, 1 second, guys. I need 2 more minutes. Okay, just 2 more minutes. Wait.